ratio test. So ratio test says that if limit n tends to infinity, a n plus 1 divided by a of n is equals to L, where L indicates any finite value. If this finite value is less than 1, then summation of a n will be convergent. And if this finite value is greater than 1, then summation of a n will be divergent. And if it is equals to 1, then summation of a n will be inconclusive. So we will solve few numericals on this. So the first numerical is summation of minus 1 raised to n cube by 5 raised to n. So by ratio test, a of n plus 1 divided by a of n is equals to, it will be, in place of n will put n plus 1, so minus 1 n plus 1 cube 5 n plus 1 into a of n will be the same one, so minus 1 raised to n cube divided by 5 raised to n. So splitting this, as we are taking the mod value, we can neglect this because it will be equal to 1 only. So combining the like terms, we will be getting n plus 1 by n cube into 5 raised to n, 5 raised to n into 5. We can split it as 5 raised to n into 5. So here 5 raised to n, 5 raised to n will be getting cancelled, and by dividing by the highest power, we'll be getting 1 plus 1 by n raised to whole cube into 1 by 5. So taking limit n tends to infinity, we'll be getting 1 plus 0 cube into 1 by 5, which will be equals to 1 by 5, where 1 by 5 is less than 1. Therefore, we can say that this series is convergent by ratio test. Second example is 2 plus minus 1 raised to n divided by 1.25 raised to n. So by ratio test, a n plus 1 by a of n will be equals to 2 plus minus 1 raised to n plus 1 divided by 1.25 raised to n plus 1 into 2 plus minus 1 raised to n divided by 1.25 raised to n. So we can take all the like terms in one place. So it will be 2 plus minus 1 raised to n plus 1 divided by 2 plus minus 1 raised to n multiplied by 1.25 raised to n by 1.25 raised to n plus 1. So by splitting this, we'll be getting 2 plus minus 1 raised to n into minus 1 divided by 2 plus minus 1 raised to n multiplied by 1.25 raised to n divided by 1.25 raised to n into 1.25. This will be getting cancelled. So we are left out with mod of minus 1 by 1.25, which will be equal to less than 1. Hence it is convergent by ratio test. Convergent, so it is convergent. So solving the third one, summation of n raised to 10 by 10 raised to n. So by ratio test, a of n plus 1 by a of n will be n plus 1 raised to 10, 10 raised to n plus 1 into 10 raised to n and n raised to 10. So n plus 1 raised to 10, we can write this as 10 raised to n into 10 multiplied by 10 raised to n and n raised to 10. So this will be getting cancelled out. So combining this, will be getting n plus 1 by n, limit n tends to infinity. Combining this, raised to 10 multiplied by 1 by 10. Dividing by the highest power, will be getting 1 plus 1 by n raised to 10 into 1 by 10. Taking limit n tends to infinity, will be getting 1 plus 0 raised to 10 into 1 by 10, which is equals to 1 by 10, which is less than 1. Hence it is convergent by ratio test. N factorial e raised to minus n. We can write this as n factorial e raised to n. So by ratio test, we know that a n plus 1 by a of n will be equal to n plus 1 factorial by e raised to n plus 1 multiplied by e raised to n by n factorial, which will be equal to n factorial into n plus 1 and e raised to n into e raised to n divided by n factorial. So we can see here that n factorial and e raised to n will get cancelled. We are left out with n plus 1 by e. We know that e is a constant, hence putting limit n tends to infinity, will be getting infinity plus 1 by e. Anything plus infinity will be infinity. So by ratio test, will be getting L is equals to greater than 1. Hence it is divergent by ratio test. Summation of n factorial by 2n plus 1 factorial. So by ratio test, a n plus 1 by a of n will be n plus 1 factorial by 2n plus 1 factorial into 2n plus 1 factorial by n factorial. So here we'll be getting n plus 1 factorial by 2n plus 3 factorial into 2n plus 1 factorial divided by n factorial. So by using the factorial rule, we'll be getting n plus 1 into n factorial. Here we'll be getting 2n plus 3 into 2n plus 2 into 2n plus 1 factorial. For we have to eliminate this term, by n factorial. Here n factorial will get cancelled. 2n plus 1 factorial and 2n plus 1 factorial will be cancelled. So we are left out with n plus 1, 2n plus 3 into, we can see here that we can take 2 common, so it will be n plus 1. So again n plus 1 and n plus 1 will get cancelled. So we are left out with 1 by 2 into 2n plus 3. So taking limit, we'll be getting limit n tends to infinity is equals to 1 by 2 into 0 plus 3, which will be equals to 1 by 6, which is less than 1. Hence by conversion test it will be, by ratio test it will be convergent. Minus 1 raised to n plus 1 n plus 2 divided by root of n. So by ratio test a of n plus 1 by a of n will be equals to, here we can neglect this because by absolute value we are going to get this as positive value. Hence n plus 1 plus 2 divided by root of n plus 1 into the root of n divided by n plus 2. So limit n tends to infinity is equals to n plus 3 by n plus 2 into under root of n by under root of n plus 1. So we'll be taking individual limits of both this one. So we'll be getting limit n tends to infinity n plus 3 by n plus 2 into limit of under root of n plus 1. Dividing by the highest power will be left out with 1 plus 3 by n divided by 1 plus 2 by n, and here will be left out with 1 plus 1 by n. Taking limit, both the sides will be left out with 1 plus 0 divided by 1 plus 0 into 1 divided by 1. So our final answer for limit n tends to infinity will be 1 into 1, which is equals to 1. So we know that when finite value L is equals to 1, it is inconclusive, for we cannot say whether it is convergent or divergent. So thank you friends, here we are finished.